Hello, everyone, and welcome to this new discussion. So today, what we're going to discuss about is some beautiful topic and apparently a controversial figure. So we are going to talk about an article that was published in Progress in Physics, and the title is on the wedgie Wheeler tortoise and the cruscal Sequeir's coordinates, and that's by a gentleman called Stephen Crothers. Um, Now, Stephen Crothers has quite a reputation, apparently in academic circles, and probably because he's in part criticizing something that is considered undebatable. And I just wanted, before we start, actually, I just wanted to put somewhere. So I think I will put on the screen somewhere, and I will put also a link in the description. So there is an actual rational wiki page on Crothers, and I never understood what was the point of rational wiki, but if anything, I'm not sure it has to do with skepticism. The reason why I say that is because, well, they consider uh, just de facto that if somehow you go against the mainstream, let's say, then you're a crank. And in fact, I think Crothers is put in the part that is called pseudo astronomy and pseudo science and pseudo mathematics and so on and so forth. Um, and I find that quite interesting. So I'm just going to read through. So by the way, I'm putting that there so that you're aware that maybe I'm talking about a crank. Okay. What they say is that Crothers was born in 1957, is a handyman and gardener and part-time amateur scientist who claims that black holes do not exist and are neither predicted by nor compatible with general relativity. His body of work consists primarily of articles that he posts either on Vajkstra, I don't know what it is, it's a sort of archive, or his own personal website, thus steering clear of the peer review process. He has also been a frequent guest speaker at the annual EU conferences held by the Electric Universe crowd. Crothers is currently listed as a staff member at the Alpha Institute for Advanced Studies, a minuscule in size and influence group of misfits and malcontents headed by free energy crank Myron W. Evans. Um, so, I mean, what is interesting is that, for example, a bit later, it's written um, uh, undeterred by his forced dismissal from academics, Crothers would soon go on to receive an honorary doctorate degree from the Maxwell Einstein University, a fake make-believe school created by his colleague and partner in crime, Myron Evans, for the sole purpose of doling out phony diplomas to his cohorts and cronies. Now, I must admit that I disagree with many people, and I have a lot of difficulties with the language being used here. In fact, I haven't seen any, in the whole half of the wiki page dedicated to this person, rational wiki page. Actually, half of it is just insults. So, for example, in 2008, Crothers and Evans each received a gold medal award from the Telesio Galilei Academy of Science, a lunatic fringe organization that hands out second-rate menial awards to virtually any disreputable crackpot and con artist. Again, I find it quite interesting. So basically, that's the kind of person I'm going to talk about. So you're kind of warned that is going to be maybe controversial. I don't know. So let's have a look at what this is about. So this was actually this is a paper that was published in 2006 in Progress in Physics, which is an actual open access journal, which is peer reviewed. So I'm not too sure what they meant in the rational wiki. And what they say here is that the title, as I said, is on the Reggie Wheeler tortoise and critical Seychelles coordinates. Now, what is the main bulk of the paper? And it has to do with a contention that has lasted, in fact, I must say, for a century, if not for more than a century. And it has to do with this equation here. So that's what they call here the Droste, Weil, and Hilbert line element. So that's the equation 1 here. So this is the space-time line element in spherical symmetry and essentially in vacuum. And it reads as 1 minus alpha over r, and then you've got this dt squared minus 1 over 1 minus alpha over r, dr squared, and then minus, and here you've got something related to the angular part of a sphere. And here, by the way, this is where c is equal to 1, so alpha is going to be equal to 2m. There should be some c's and g's everywhere, but people use so-called reduced units here. Now, what they want to show here, and that's a contention I'm talking about, and in fact that has been clashing in different instances, is that Drost or Droste, I don't know how you pronounce that, showed that R, if you have a R here, it has to be between alpha and infinity. Okay, and in fact, Weil had basically said the same thing in his paper. Now, the thing is that as I will put a video I will put a link somewhere, but as I've shown and discussed somewhere else, actually Schwarzschild found a different solution than this one. Okay, so he actually selected, he had a different expression for the line element that had the variable lowercase r, but then the function was not the same here, it was not the same there, etc., etc. And there, Schwarzschild imagining that the lowercase r could go from 0 to infinity. Now, in modern texts, what people do is that they actually take this expression, which is not the expression that was chosen by Schwarzschild, and they actually put r, the lowercase r, to go from 0 to infinity. And it's unclear why this is a problem. So, for example, I have found some arguments where people say, well, if we take the prescription of Drost, for example, that r is between alpha and infinity, then we have like some geodesics somehow are going to stop at 2m. So geodesics in terms of these coordinates r here are going to stop at 2m. And according to them, that's a problem. But stating that this is a problem is already, giving away, let's say, part of your expectations about the meaning of R. Okay, and in fact, that's what Crothers actually mentioned here. He says, well, according to this orthodox view, R here that appears in the equation 1 seed below is a proper radius. So that's something that must go in principle to a sort of what they call mass punctum or mass punct, which is basically a point mass that we would expect, like in a Newtonian problem, or like in a point charge problem with the Coulomb's law, for example. And therefore this r that is interpreted as a proper radius can go to 0, and in a sense ought to go to 0. And if you were to again look at geodesics and as a function of what is called the affine parameter or affine parameter, then it must go apparently to 0 as well. And again, that's something that that everybody kind of tend to say. And then there is this idea that a singularity must occur where the Riemann tensor scalar curvature invariant is unbounded. Okay, and according to the author here, essentially none of these particular assumptions have been proved to be true. They are simply stated as is. And in fact, many people actually mention. I've read a critique by Toft of what's going on, for example, of the author, so of Crothers. And well, actually, I'm not even sure I understand. So the point here is that many people would claim that this particular form here, in and of itself, is sufficient to tell you everything, in a sense. And and so we can't necessarily decide, anything. Only it's just a change of coordinate that is going to, make things a bit different and so on. But it's obvious that that's not the case. If I really adopt strictly this particular expression in equation one here, then obviously the physics I'm going to describe is going to be different if I adopt this view or if I adopt that view here. Sorry, or this view. Um, it has to be different, right? Because R is not bounded by the same values. So whether this particular, so by the way, people are going to tell you, and that's what people have told me in the comments, and I knew about this particular generic form for the solution in vacuum is what it has been proven, let's say, by Birkhoff. So that's called, like, that's a solution. That's the statement of Birkhoff's theorem, is that basically this is a solution to the spherically symmetric problem in vacuum um, of Einstein's equation. Okay, but then there is ambiguity on what R represents, and the ambiguity is in part contained in the values you want to bound this R with. And essentially, that's the point that Crothers is making, is that essentially, depending on which view you want to adopt, you're going to get different space-time manifolds. So his main claim here is that there is, for example, people try to resolve the problem by saying that there are. I think this is, sorry, I apologize. Yeah, so by saying that at r equals alpha, we've got what is called a coordinate singularity. Um, and so it's a non-physical singularity, while we have at r equals 0 a true physical singularity, etc. And this is interesting, and that's something I will actually come back to, in fact, to the whiteboard video, because I really want to talk about this. The notion of coordinate singularity, whenever somebody actually gives me an example of it, is, in my opinion, always misleading, and in fact, always, at least in the examples I've been provided, it's actually always invalid. Um, so that's something we can discuss later. Maybe some people can explain to me how I'm wrong. But in my view, what happens, and I'm just going to state that very quickly, um, is that cha- changes of coordinates, so coordinate transformations, uh, in mathematics and even more so in differential geometry, they need to be invertible. If they are not invertible, then they are not legitimate coordinate transforms. So it's not like you can take whatever you want to actually annihilate something like that. You've got to, you've got to take proper coordinate systems that are invertible. Now, all the kind of coordinate systems like the Eddington-Bekenstein, no, it's not Bekenstein, sorry, it's Eddington, Finkelstein and Kruskal and Sekeres, all of these coordinate transforms, they allegedly get rid or bypass the coordinate singularity, but they are themselves singular at the event horizon. Okay, so if they are singular at the event horizon, well, that means that they are not invertible. Um, so that's it. Like at that point, they don't exist, and therefore at that point, they can't be inverted. Um, and so I have no idea how people can kind of, be happy using these things. Um, Many people will show me examples where we can get a fake divergence at, for example, at some coordinate that is 0, etc., that actually does not exist, and so on. But again, if the person were to use that coordinate transform that is singular at zero and then use it as if it were not, then of course it would lead to pathologies for the line elements. So basically, that's kind of the point he's made. And so he actually, goes through the calculation. So this particular here form that is given in equation 2 is a general form that is going to be put forward. Here, the C of R stands for sort of square root of curvature. And at least you can view that this way. And then basically provides a solution for that. So these are functions, right? And so that's kind of basically how these things work. So he actually goes into the mathematics of it. He actually goes through the different kind of things that are done. So that's where this kind of singularity are going to show up in these different coordinate transformations. And then actually retrieves the work that was done by Schwarzschild. So I think here he gives a general formulation for the kind of the square root of C function we had seen earlier, and then basically you can retrieve the Schwarzschild prescription a bit later by setting the n value to be 3 and r0 to be interpreted as 2m, I believe. No, that's to be 0, sorry, because that's where the physical um, divergence is going to happen. So essentially, that's it. So of course, it's not like I have time to go through the detailed mathematics of it. You're aware. I've told you this is a allegedly controversial viewpoint. In my view, this person and actually other authors are pointing out what they believe to be at least one or multiple mathematical discrepancies. Um, and as far as I've read, to be honest, most commentaries I've read, they are simply just dismissing this kind of questioning. And literally dismissing. It's like, oh, you're not smart enough to understand that all of these things are the same. Well, it's a matter of course that if you take the very same equation with the same symbols in there, and you don't give the same numbers, like the same interval of support for these variables, then of course they don't correspond to the same things. Um, and again, some people are going to say, oh yeah, but if you fix yourself to, so let me go back to the very first one. I'm sorry, I'm jumping around here, but some people say, well, if you actually do that, you're just exploring a part of the manifold, right? So a manifold is described by what is called an atlas, and this atlas is essentially an arrangement of charts, and here you simply have one chart that is characterizing one part of the atlas. So that's a current modern interpretation where we adopt, let's say, we adopt the Hilbert viewpoint that R actually goes from 0 to infinity, but then we can split it into 0 to infinity and then 0 to alpha. Okay, so that's the current viewpoint being held. But some people have a completely different viewpoint where this is actually the thing. Okay, so you've got R is between alpha and infinity, and then it's actually a function itself of lowercase r. So R here is a curvature, and then it's a function of the lowercase r, and this function is this one. That is, sorry, this one here. And that's actually R star. Um, and you can check obviously that when R tends to 0, so if you imagine that R here represents a sort of physical radius, a real one, then r can go to zero, so to the point mass, and in that case, r star, the curvature, is going to be basically alpha, so the Schwarzschild radius. So that's basically what Schwarzschild kind of came up in his first paper um, in 1916. So as a kind of summarizing part, according to this author, and I must admit that personally, I mean, I wouldn't talk about it if I didn't find it intriguing at the very least. And so what these people say is that the standard school of relativists, whatever that means and whoever this is targeting, has never provided any rigorous argument as to what constitutes a radial quantity in Einstein gravitational field. And to be honest, if you actually look at discussions in textbooks and discussions in forums, etc., basically people tell you that, you know, radial quantities don't mean anything, or like essentially there is a field that somehow people have been told to accept something, but maybe without necessarily understanding clearly. At least that's the way I feel about it. So yeah, so this idea, for example, that equation one doesn't mean anything in and of itself, I think is true. However, as soon as you provide the range of values to be covered by R, then it becomes something, and it is telling you something. And that's where people tend to disagree. That's where the tension lies. Now, do I think that it means that um, exist or don't have any theoretical underpinning? I think it. I think there is some undermining of black hole theory. Um, as far as I'm has focused mostly on static black holes. So, for example, Toft criticizes Crothers on the ground that some of his critiques don't work for Kerr black holes and so on. I think this is irrelevant. Um, in fact, I didn't understand, I didn't see any actually critique from Toft about the static aspect of it, really. Um, and basically, I agree as well here, or at least again, this is intriguing. The motivation to the Eddington-Finkelstein coordinates and the Kruskal um, uh, Sekeles extension is due to the erroneous assumption that the variable r is a proper radius and can therefore go down to zero. Um, so that's what they claim. I would recommend that people read it. You know, I'm sure people are going to say that this is all rubbish, that he is a crank, and so on. But then you really need to say what's going wrong. And I'm going to I'm going to continue actually looking at papers that basically go along this kind of line of discussion, because I do think that the mathematics tends to be treated a bit too casually. So, for example, Singh had proposed a set of criteria that the solution to Einstein's equation had to satisfy. And for example, Schwarzschild did abide by these particular criteria. One of them being, for example, that a signature could not change. That was a requirement. Another one would be that ds squared had to be positive. There are some stuff like that, like the determinant, I think, had to have a particular value as well and not change sign, and so on and so forth. And so all of these things are not satisfied anymore. People simply have things that go to infinity. They've got time that becomes space, etc., in different parts of space time and that are stitched together, etc. And I think that this is fair enough to request whether or not some extensions that are being put forward are truly legitimate and whether they are really the only ones that can be proposed in terms of solutions to a centrally spheric problem of a point mass in Einstein's equation. So basically that's it for this paper. Again, if you want to criticize and so on, please by all means do it. I'm going again to cover more articles along these lines. Some of them are going to be technical, so I won't be able to go through the most of the details. However, I will obviously cover the parts that address this particular tension, at least among some mathematicians or kind of self-learned mathematicians or physicists, and in fact, and other people in the field. Okay, it's not just gardeners and handymen who disagree with this view. Okay, so if you've got any comments, questions, if you want to like, dislike, by all means do so, and then I will simply continue put this in, for discussion in further videos. Okay, so see you in the next one.